For 24 and 25, we have to write the linear inequality with the given graph. And so we have to refresh our memory with these here. Okay? So if we look at number 24, we see that it is a dashed line, right? So dashed means that we're going to have to be one of these here. And we see that our shading is below our graph. So below is actually less. Okay, so we can kind of see that up here. This is less than. And then this is greater. All right, so we have less than and we have the greater than. So less than, it's dashed, and we're shading below. Okay, so we know that we're going to have y is less than something. And we have to find our m and we have to find our b, just like we did when we did this for slope-intercept form. So I'm going to rise 1. I'm going to run 1. So 1 over 1 is just 1. Now for part b, we're at -2. And so we would have like y, so slope-intercept form is y equals mx plus b. We know we're not using equals because we have the shading, so it's either dashed or solid. We know it's dashed, less than. And then we have our m, so 1x, and then our b is plus, usually plus, but it's actually a negative here, so we're going to put -2. All right, then in 25, we're going to switch to pen since it's kind of got a glare on it. So in 25, we see we have a solid line, okay? A solid line means that we have to have the little line here, the equal to part. So again, this is less, and this is greater. And we have to decide, are we less or are we greater? And the line is shaded below, so this is down. So that's less, and because we have a solid line, we have the equal to part. So we know we're going to have y is less than or equal to. Now we got to find that m and that b. So m, how much do we rise? 1, 2, 3, 4. And we run 3. Okay, our b is where does that line cross the y-axis, which is at -4. -4. So again, we're plugging that into mx plus b. So y is less than or equal to m, which is 4/3 x, and b, which is -4. For number 26, we have y equals the absolute value of x plus 3. We discussed in class that if that number is inside of the absolute value, which it definitely is, we can see those absolute value symbols there, and that 3 is inside of those absolute value symbols, then we start at the -3 on the x-axis. So I'm going to go to the x-axis. I'm going to put a point at that -3. And then when we actually graph the V-shape, we're just going up 1, right 1, up 1, right 1, up 1, right 1. And we do that like 3 or 4 times is good. So I did it 3 times. But we also want this to be symmetric. So I need to go up 1, but left 1. Up 1, left 1. And I'm going to do about the same amount as times. So I've got a 3 on each side. And then I draw the V. Now, so you're going to get points for drawing this correctly. Then it says, take this graph and translate it 4 units to the right. So right is going this direction. What would the equation be? So let's go over here to the graph and let's move it. So if I go from the vertex and I move it 4, 1, 2, 3, 4, I land at 1. I'm going to have you guys go ahead and graph that V shape. So I would have up 1 over 1. And then I would also go up 1, left 1. Okay. Now, for my equation, we know that we started at a positive 1. But just like up here, whatever was inside of here, we did the opposite of. So when I draw out my equation, I've got y equals the absolute value, and I have x minus 1. So when I change it in here, I have to do the opposite. Okay, so x minus 1.